So as I told, RCM should always start with the business goal in mind. Without a business goal, there is no purpose in doing RCM. The practical cases where I have been involved is a chemical company wanted to lower the price by 18%, price of its product by 18%, so that they can compete with the China. And how they did it? They focused on reducing maintenance cost, energy cost, and improving steady state availability. That is how they did it. Because once you improve steady state availability in a process plant, you you contain the cost of material loss. In a process plant, with every start stop, you not only lose energy, but you also lose a lot of material along with it. So that was the business goal. How to compete with China by lowering the price, and by lowering the price means lowering energy cost. As I told you, in process industry, energy cost is huge, material cost is also huge, and maintenance cost substantial. Once you increase steady state availability, naturally you reduce maintenance cost and you reduce energy cost and material cost. In an iron and steel company wanted to add 6% to the bottom line, because iron and steel company again they were fighting with China, so they wanted to improve the profitability by 6% by improving the yield of production from 92 to 98% by improving equipment reliability. And this was done. This was against this object. RCM is done. What idea it gives you is that RCM is actually a problem-solving process. Against a problem, against a big business problem, you start a problem-solving process. That how do we achieve that business goal by through a problem-solving process of reliability-centered maintenance. So that is interesting. To engineers, problem-solving is always very interesting. So an FMCG company wanted to raise their productivity by 25%. So this is a business goal. Aluminum company wanted to not to replace an old machine. A machine was 75 years old. They didn't want to replace it by a new machine, which cost them a huge amount of money. So they thought that if I can improve the productivity of this old machine by 10%, I did not invest in the new machine. So that was the business goal. With that business goal, they did RCM. So like this, you can see that RCM always starts with a business goal in mind. It is a problem-solving approach to maintenance. That what is the minimum I should do to reach the business goal, but at the same time without compromising safety, risk, and at the same time increase the life cycle cost of the asset. That means the asset is the most important thing, machine is the most important thing to give me money. So how do I keep the machine going without stopping? So step number one, now we come to the process. Step number one is criticality analysis. The fundamental mantra is focus 10% to 20% of what? Of the machines. In a process plant, typically has over 1,500 machines. So do I focus on all the machines? No, we simply don't have the resources. And nowadays there is really a resource crunch in terms of manpower. So with the limited manpower, what to do? We first narrow it down. We narrow down the problem to only the critical machines. Now, criticality analysis has different styles of doing criticality analysis. TPM has a particular style of selecting critical machines. Then if you look at critical machines from the environment point of view, you have another format. So RCM cuts down all that format and sticks to a very simple format, is that it finds out the criticality, the system, equipment 1, equipment 2, equipment 3, you line up the equipment, and then from your SAP or recipe or your maintenance history, you find out a number of failures that have taken place over a period of time. You can take the period of time is up to you. You can take it 1 year, 6 months, 3 years, 2 years, whatever record you have, depends on the record. But less than 6 months does not give very good results. A minimum time period of 6 months I have seen is required to fill up this number of failures, and then the total downtime in the same time period. Total downtime in the same time period that we are finding out the number of failures, and all you do in the last column, on the fourth column, is F multiplied by T. That means number of failures into the time. That gives the weightage. So if I have 15 failures and there was 15 failures in a year, let us take for example 15 failures in a year, and 100 hours was down because of those 15 failures, then 100 into 15, I have made a calculation mistake, it should be 1500. Similarly, equation number 2, and then we find out which factor, FT factor, is the highest. So we then rank them as per the FT factor, and then select the 10% of the machines, 20% of the machines as it feels comfortable. Because it is not an overnight story. You have to stick with the machine for quite some time to get the best results, optimize the results and get the best results. So you rank it and focus on the first 10 to 20%. Here is a practical example of a criticality analysis taken from the field. So we have boiler, quench tower, DT circulation pump, AAT tower, fat circulation pump, and all that. So they have taken the failure rate, and how many months they have taken? 30 months. You can see that they have 30 months. And again, in that 30 months, they have noted down the downtime, how much downtime was associated with 8 hours, 8 failures, and then they did F into D. And as you can see from here, this fellow, boiler, occupies the number 1 position, followed by fat circulation pump, and then others. Oh, sorry, followed by 461 quench tower, then circulation pump, and then IID tower. So where do I focus? Do I focus on the drum cooler? Maybe yes, but I should focus more on the first one, boiler, and then on the quench tower. I should keep on correcting one by one, or you can have different groups also. One group is looking after this particular equipment, second group is looking after second equipment, third set of equipment, like this. But once you get through these first 10 or 20 equipment, you have definitely made a lasting change in the performance of